So now let's go to version 2 of elasticity formula, which I also refer to as a linear version, linear formula of demand. So here we still talk about demand. We use that as an example, okay? And this version will be able to demonstrate to you a clearer why for a demand elasticity, price elasticity of demand, we can observe a negative value for this elasticity. Okay, so let's think about the original version. In this case, it is percentage change in quantity over percentage change in price. And then the question is, what is your percentage change in price? Previously, I put a P there to tell you it is the causal, the independent variable is P in this case. Okay, so percentage change, what's the expression? That is how much Q has changed as a quotient to the overall level of P, right? If you can recall, previously, we introduced the percentage change, the population, percentage change in population by putting the change in population, which is 1,000 people, over the total, right? The total level of population, right? So on the top is the delta, in the bottom is the total people, right? So that's how percentage change should be expressed. So here, the percentage change of quantity is delta Q over Q itself. The percentage change of price is delta P over P itself. And then we rearrange this. We have delta Q over delta P multiplied by P over Q. Okay, so just pay a little extra attention. So this one seems to have 4 parts, but actually only 3. So this expression, this is the linear version, okay, or the slope version of elasticity, okay? So here there are 3 parts. One is the price itself, the second is the quantity itself, and the third is delta Q over delta P overall. And overall, this is a slope concept, right? Remember, for a linear function, like y equals to a plus bx, right? Delta y over delta x equals to b. That is your slope. Okay, so this is how you should consider delta Q over delta P. All right. And here, let's go to our question then. For a demand function, Q equals to 100 minus 3P, okay? Calculate its price elasticity of demand when P equals to 5. So, an analogy that I make about solving this problem is it's as if it's a jigsaw game, right? You have those pieces of information and you need to, this formula is the original graph of a jigsaw game that you're referring to, and you're just trying to find those pieces and to put them together. Okay, so here we have this information, P equals to 5, and we are given this linear formula of demand. That's why I also call this a linear formula version of elasticity, right? And here, the first thing that we can find is Q. right? You need this Q to calculate the elasticity, right? How do you calculate Q? Just plug P equals to 5 into this expression, right? Into this demand function. So it's 1,000 minus 15 is 85 as the result. That's your Q. So we have P, we have Q. The last question is, what is delta Q over delta P? Right? So here, let's refer to something that you're familiar with. So here, y equals to a plus bx, then its slope, which is b, right, is expressed as delta y over delta x. So here, in this case, if you're ever confused, just side note this. Here is as if it's y equals to 100 minus 3 times of x, right? Your q is the dependent variable, namely in the position of y, and p is the independent variable in the position of x. So the delta y over delta x, which is the slope, which is supposed to be minus 3, and in this case, your y is q, your x is p. We just need to replace the letter after the delta sign. So here, delta Q over delta P is minus 3. So you have delta Q over delta P, you have the price, you have the quantity. Then to calculate elasticity, what you need to do is just to plug them in, right? The first term is minus 3. The second term, for the second term, on the top, which is the price, that is supposed to be 5. In the bottom, 85. Then you just need to head on your calculator to work it out, the number, right? So it is 1 over 17. So the result is minus 3 over 17. So it's the absolute value of E is smaller than 1 because 3 is smaller than 17, right? So we can infer that the consumer is inelastic. Okay, when you're reporting the elasticity itself, you should report the decimal version converted to percentage of this, or the decimal version of this, or the fraction itself, no matter what you whichever you prefer. Okay, but to discern whether this elasticity falls under the inelastic category or elastic category or unitary elastic category, you need to look at its absolute value. Okay, so now let's tend to answer the original question. Why can we see the negative sign for the demand, right? For the elasticity of demand from this expression. So here, look at the price and quantity. In economics or in business, they should both be positive. We should have a positive price, right? And we should have a positive quantity, right? And then the question is, this delta Q over delta P, which is a slope term, is the determinant of the sign of the elasticity. In the case of demand, right, where we have P and Q changing in the opposite direction, law of demand, right? In that case, your delta Q over delta P should be a negative sign, should be of a negative sign. Then these two terms are positive and here multiplied to a negative, then it tells you for elasticity, price elasticity of demand, we have a negative sign, right? It is corresponding to, it is consistent with our original understanding under the percentage change version of elasticity. And it is also consistent with the law of demand in the sense that quantity and price, they are changing in the opposite direction. Even if they are in the percentage, they are still changing in the opposite direction. Okay, so here I'm just giving to you one version. So sometimes you may see an inverse version in which price is expressed as certain level of as a function of quantity, A minus BQ. Okay. I'll just give you a case, say P equals to 100 minus Q. Right? In that case, minus 2Q. Let's do 2Q. In that case, if I give you, say P equals to 5, okay, you can still utilize this to calculate the Q, right? So you just need to solve this function. Say 5 equals to, let's do 10, making the calculation easier. P equals to 10, 10 equals to 100 minus 2Q. So it's 2Q minus, move to the left-hand side, change to positive, equals to 100, now minus 10, which is 90. So Q equals to 45. Okay, so here we have the P, we have the Q. The last question is, what is delta P over delta Q? Okay, some of you may think is minus 2. Okay, it's a good attempt because you see this kind of double deltas. You're looking for the quotient of deltas and you relate them to the slope. That's a good start. But here you need to step back a little bit. Okay, because minus 2, that is the slope of this. And here, in this case, your P is Y, your Q is X, because that's an inverse demand, right? So just regardless, minus 2 is always delta Y over delta X. So here you just need to figure out what is Y, what is X in this case. In this case, Y is P and X is Q, right? So it's minus 2 is actually delta P over delta Q. But what are you looking for in this expression? In this expression, you were asked for delta Q over delta P. Then before directly plugging minus 2 into this expression, you need to find delta Q over delta P, which is the inverse of it, right? So in this case, elasticity now is delta Q over delta P by P over Q. Okay, so here, delta Q over delta P is minus half, and your price is 10, your quantity is 45. So that is supposed to be your result. So it's minus 10 over 90, which is minus 1 over 9. Again, the absolute value of this elasticity is smaller than 1. We have inelastic consumer. Here, the key thing is for this minus 2, for this B term, right? Now you need to give it a second thought. You need to stop here a little bit and plug P as Y, Q as X, right? And then compare to the original expression and to find the right form of slope to plug into your formula to calculate elasticity. That's the only thing that needs a little bit extra precaution. Thank you.